third video going through the slides. We've covered everything up to slide 36. Slide 36 is just pointing out that the total number of atoms are the same on both sides, but not the total number of molecules nor moles. That what we're doing is we're paying attention to atoms when we balance, and that follows the law of conservation of mass. But we have other ways of doing measurements that may not be shown to be equal on both sides. And then we have this repeat piece where we talk about it, and then a quick question about measuring the carbon inside coal, and then measuring the ash of the barbecue, and the ash is significantly less weight, and as you can see in the reaction that what's going to happen is I'm going to make carbon dioxide. So what happened to the extra mass is just about reading this piece and answering the question. So pretty straightforward. We're now going to go on to three-step problems. And so in a three-step problem, we give you this guide called a mole roadmap. And the mole roadmap is a way to identify what ratio to use and how many steps it's going to take. So you first decide where you're going to start. Are you going to start with mass, or are you going to start with moles? A is just a placeholder for the first substance. In the book they call it given, but when you read the book, read a problem, you are given a number with a unit, and that's either mass or moles. Then what you do is you decide which way you're going and what else you're going to do. So if you're switching between mass and moles in a one-step problem, you use molar mass, and you either use the grams on the bottom going forward, or you put the grams on top going backwards to mass. So that's why there's two arrows here. If you're switching substances, A being the substance that you're given, and B being a substance you're trying to find, then you would use a mole ratio to switch between substances. So what we're going to do is we're actually going to go all the way across from mass to mass. So I will say something like the mass of carbon, and we want the mass of carbon dioxide, and we'll switch from one to the other to the other. So that we call this a three-step problem because we will be using molar mass, then we will be using mole ratio, and then we'll be using molar mass again to go all the way across this. We could stop at any point, so we could do a two-step problem, 2, 1, 2, and we will be doing that one later. So here is an example problem of a mass-mass calculation. I've identified my starting point, I've identified my ending point, and I've seen that what I need to do is use molar mass, so that's my first ratio. Then I need to use mole ratio, that's my second step, and then I have to use molar mass one more time. And notice that the beginning molar mass had mass or grams on the bottom, and the ending one has mass on top with grams on the bottom. So we've switched, and switched all the way across with our three-step problems and three ratios. And what's great about mass-to-mass calculations is this relationship or pattern will not change. We will always use mass on the bottom, moles on top. We will always put the moles of A, the beginning substance, on the bottom, and the moles of the beginning substance on top, and then reverse the molar mass, but using the new molar mass of B. So what's nice about mass-to-mass calculations is there's no thinking about it. You just repeat what you saw in the previous example or problem. So your job here would be to read through this problem. Here's the beginning, which is the question, blah, 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 blah. Here's a number with a unit and a substance. And then to think about how you might use the mole roadmap to find these two things. So here I'm going to start with grams, and I'm going to go to grams. So here I need to start with grams and go to grams. So that would be three steps. So down here, I see my mass, molar mass, with moles on top. then mole ratio, where I use the balanced equation, and then molar mass, and this time the moles is on the bottom. And I get my answer, which is grams of a new substance. So I began with CaC2, and I'm going to end with a new substance. At the beginning, step 1 and step 2 are simply to gather the information that we'll use in the ratio. So we add the pieces together, and then we add the pieces together, and then we take the balanced equation and create a ratio with that to make our mole ratio. Now we take the pieces, we have this purple color, and then we have this combination that goes in the middle, and then we have, I don't even know what color that is, brownish color, and we put it here. All right, multiply the numbers on top, starting with the first number, 5 times 1 times whatever this is, times whatever this is, which is 24, 25, 26, about 26. And then you get the answer, and then you do the bottom, and again, you add these together, 40 and 24, 40 and 24, 64, so about 64. And then here you're using the coefficients of the balanced equation. Holy mackerel, they're both 1. That wasn't a very good problem. Okay, so they both become 1. And then you're done. And so then when we go over the worksheet, you'll see we'll do the same thing. We'll start with a mass, we'll do molar mass, we'll do molar ratio, we'll do molar mass. At the beginning, moles is on top. At the end, moles is on the bottom. Multiply the top numbers, 5 times 1 times 1 times whatever I said that was, 26. And then you divide by the 64, the 1, and the 1, and you get your answer. Easy peasy. We still have 2-step problems up ahead. Oh, and we're all done with the slides. So when you do this, you can be all done. All right, that's the end. Good luck. Please finish all the slides and look at all the videos.